All right, here we go. Still committed to this going backwards craziness. So it just says find the zeros of the given function. Back when you did it, it said using algebra. What does that mean? Well, we look at this, we say, hey, we're going to let 0 equals, because that's what it's really asking. Where does y equal 0? So we're going to factor out an x. We'd be left with x squared minus 144. Hopefully you are getting real good by this time, noticing this is a difference of two squares. And then you say, aha, my zeros are 0, 12, or negative 12. Let's go on to this one. Similar situation. 0 equals, now I can take an x out of there. So I have 8x squared plus 2x minus 1. Now this is a little bit of a stinker, and it might take a little trial and error, but let's tackle it. 0 equals x times one thing we got to be careful of is this might not be factorable, and I'm thinking it's not, because if I tried a whole bunch of stuff, there's no way I'm going to get a 2 there. So find the zeros of this, and if it doesn't work by factoring it, 4 and 2, oh, wait, 4x, 2x, there's hope, plus 1 minus 1. I was going to stuff this into the quadratic formula, but I noticed that it's factorable. So if I FOILed this out, I would get this, so we're all good. But now I'm going to look for my zeros. So that'd be 0. Take the opposite of this, which is 1. Divide by that, it's 1/4. Take the opposite of this, which is negative 1. Divide by that, it's 2. So there's my 3 zeros. Okay, for number 10, it says find the vertex of the parabola. Remember, parabolas are either going to be y equals ax squared kind or x equals ay squared kind. Notice the x is squared. So we're gonna say, hey, it's one of these, not one of these. And the generic form is this. So we got to get this to look like that. This is what needs to drive the machine. In other words, we need a perfect square trinomial. How are we going to do that? Well, it's called completing the square. You take the 5, kick it over, and we take a look at this. Negative x squared minus 4x. We create a space. Maybe this is all coming back to you now, plus a space. Here's the problem. In order to complete the square, this has to be a positive 1, not a negative 1. A lot of students now might think, oh, I'll just multiply everything by a negative. That'll take care of it. We don't want a negative attached to this. So how do we get rid of that negative? We're going to factor it out, which is very significant. And then we'll just put the rest of the stuff where it belongs. Take half of 4, which is 2, square it, which is 4. Now we have a perfect square trinomial. We'll deal with this in a minute. A lot of people will instinctively put a negative 4 right here, and then they will get this wrong because you got to look back over here. There's a negative 1. When that negative 1 hits that 4 that wasn't there in the first place, that is a negative 4. So you actually have to add a positive 4. Now if we make this thing look like this, we get y equals negative 1, x plus 2 squared. That's why we need a perfect square trinomial, because it factors into one of these, plus 9. How do we get our vertex from this? This is left 2, up 9. And there's your vertex, if you were to graph it. Okay, so I got this problem kick-started a little bit. The vertex is 0, 0, which is right here, which means it's kind of an easy kind. And it passes through the point 1, negative 2. That's kind of significant, because if it passes through there, we can see that it's going to look like this. Now, how do we take this information and get the equation? Well, because it's like this, I talk about Pac-Man eating the x-axis. This is going to be an x equals a y squared kind. Now, because the vertex is 0, 0, it makes it easy because there's no change here, no change here. We just need to figure out what this is. Well, we're going to take advantage of this point here. This is my x, this is my y. So I'm going to go x equals a times y squared, which would be 4. Divide by 4, and I get a is 1/4. And because it's going to the right, I know that it's positive. So I'd get x equals 1/4 y squared. Problem is, this was totally fine in Algebra 2. Then it was totally fine in pre-calc for a while, which is really strange. But then they started to isolate the squared. So I don't know, it's kind of weird. So we're going to multiply that by 4, multiply that by 4, flip it around, we get y squared equals 4x. Okay, so I hope this doesn't bore you, but you can see I erased all my work. I just checked the answer and it's wrong. Problem is, I think this is just a bad question because there's no information in here telling you which way the parabola is pointing, because I just showed you one way, but another student might go, aha, it goes this way. So this is good for learning. I'm just chalking this up as a bad question. Mathematicians out there, if it's not, reach out. All right, so now I'm going to take it a different route. So I know this is a y equals a x squared because I drew it differently. I also know that a is negative because it's a sad face. That's how I teach it in my class. And to find a, I'm going to plug it in there. So y equals a times x squared, which is 1. And so now I know a is negative 2. So I'm going to put that right here. So y equals negative 2 x squared. Again, because the vertex is 0, 0, there's no change there, no change there. And this miraculously matches the answer in your key. So that's how they wanted you to do it. The other way, I don't think it's wrong, but enough. So this says write an equation for a linear function, which is telling you y equals mx plus b. In other words, find the slope, find the y-intercept. This is old school stuff. And look at, guys, if you just use your brain a second, that's telling you 0, 4. So by just giving you this unique point, they're telling you the y-intercept is 4. So we'll tuck that away. Now we need to find the slope. Well, I'm going to call this x1, y1. I'm going to call this x2, y2. And so the slope is y2 minus y1 all over x2 minus x1. So we get negative 11 over 5. There's my slope. So I'm going to put these two things together. Y equals mx plus b. Okay, so this one, saying profits for the first quarter of the small business were $10,750. In the fourth quarter, profits were more. What's the percent of increase? I'm just going to take this the easy route. Find out what their increase was. So it increased up to $376.25. And the increase is compared to what they used to have. So I'm going to go 376.25 divided by 10,750, and that will give me a percent. So you can see after I divide this out, I get 0.035, but they're asking for the percent increase. So I got to turn this into a percent, which would be 3.5% increase. Okay, number 6. This is just basic graphing skills. So what happens to this when I change it up like this? This is my easy one. That's just down 3. That negative means over the x. And that 2 means it's vertically stretched. You guys have done so much graphing this trimester. You should be pretty good at that. Vertically stretched by 2. And that's your answer for number 6. All right. Let's go on to number 5a and 5b. So this is saying find the inverse of the function. There's a step 1, step 2, step 3, step 4 kind of thing going on here. First thing you're going to do is replace that with what it is, and that's y. Second thing you're going to do is you're going to flip-flop the x and the y's. And then you're going to solve for y. And I'm going to turn this around so I get 5y equals x minus 12. And then I just checked the answer. All they do is divide by 5, divide by 5. So you get y equals x minus 12 over 5. There it is. Same thing here. Y equals negative 3x minus 2. Flip-flop the x's and the y's. That's the inverse. And now solve for y. I'm going to add 2, add 2. I'm going to flip it. Negative 3y equals x plus 2. Divide by negative 3, divide by negative 3, and I get y equals x plus 2 over negative 3. Number 4, the key is Phil Collins' song called Inside Out. In other words, this is the same thing as this, and this is on the inside, so we have to do that first. In other words, plug 4 into G, which means 4 squared is 16, 16 minus 4 is 12. So this turns into f of 12, which means put the 12 right here. 2 times 12 is 24, and the last thing you get is your final answer. So with that in mind, this is the same thing as this. So we're going to put negative 1 into f, which is right here. So 2 times negative 1 is negative 2. Now we're going to put this into g, which is right here. Negative 2 squared is 4. 4 minus 4 is 0. Okay, so cruising along, we look at this and we go, aha, this is a parabola, because this is really y equals x squared. So with that in mind, we know it's one of these or it's one of these. Because there's an invisible 1 here, we know it's a happy face. So let's get down to business and actually graph it. So this is right 3. That's up 2. Because it's a happy face, it goes like this. It's asking for the domain. What's the domain? That's my x's. What's that mean? How far left, how far right does it go? Well, this would keep widening out forever and ever. So my domain is negative infinity to positive infinity. Now my range is my y's, which means how high does it go, how low does it go. You always start with how low it goes. And that point right there is 3, 2. What's the lowest point? 2. So the range would be bracket 2, because it definitely touches 2, and then it goes up. So that would be to infinity, parentheses. Okay, so once again, the graph got deleted from this packet. Nobody said anything, a little confused, but is the above graph a function? By the way, I just peeked at the answer, so I made a problem up that would match the answers. And if we just say, hey, vertical line test, how many places does it cross it? 1. That's a yes. If it's something like this and you go like that, you would say no, because it crosses in 2 places. Not a big deal. What's the domain? Well, again, goes left forever, right forever. We got to think in terms of that when we're thinking domain. So that'd be negative infinity all the way to positive infinity. The range, again, starts at negative 6. It gets there and it goes up. So that would be negative 6 all the way to infinity. And the last problem, in reverse. The first thing you have to think is, this can't happen. You can't have a negative underneath there. So it all hinges on what you believe about this stuff, 9 minus 3x. How do you say that this stuff can't be negative? You say it by saying it's greater than or equal to 0. So this is how you approach these domain problems. So I'm going to subtract 9, subtract 9. Negative 3x is greater than or equal to negative 9. Divide by negative 3, divide by negative 3. Because I'm dividing by a negative, I flip the inequality and I get x is less than or equal to 3. This is the algebra 2 answer. But if I put it on a number line, it'd look like this. How do I say that? Negative infinity all the way up to 3. Congratulations! You're done. Congratulations, I'm done. Good luck, guys.